This is the instructional video for the St. Martin's University Cable Inc. project for BA320 Operations Management. In the next few minutes I'm going to show you how to make a Cat5 network cable. We're going to use Cat5 LAN cable. It's just a straightforward cable. The Cat6 cable, as you can see, is a bit different. It has a higher gauge. This is 23 gauge wire. This is 24 gauge wire. It's thinner. It will go into our network connector pins easier. It's going to make the course a little bit easier to do. It's also not as shielded. You'll see that the Cat5 cable just contains the 4 twisted pairs of wire, whereas the Cat6 cable has an external shield. It's much thicker. It has an internal shield that separates the pairs to reduce crosstalk. It's a much more robust cable. We may do some of this in a later course, but for now we'll work with the Cat5 cable. What we're going to do is put on an end to this cable. The end includes the network connector. This is a Cat5e pass-through network connector. This is the stress relief boot for the connector. The cable that protects the cable end. For this project we'll need our cable tester, so when we're finished we can make sure that our cable works. We'll need our crimping tool, which will also serve as our wire cutter. This is the wire cutter portion. This is the crimping portion, the center one that we'll use to crimp the cable in place. We'll need a wire stripper and a pair of scissors. In addition, we need our RJ45 pinout diagram. This uses the T568 wiring pattern, which has the twisted pairs wired into the connector in this order: 1 white orange, 2 orange, 3 white green, 4 blue, 5 white blue, 6 green, 7 white brown, and 8 brown. You'll notice that in the diagram the connector is upside down, so you want to make sure that as you're running the wires into here that you're holding the connector with the pin down. Now you'll be given a length of wire, and you'll need to take that length of wire and cut off a piece to the length indicated in the assignment. We'll just use our cutting tool to do that. Place it here, one good clip. So the first thing I need to do, and you need to remember to do this especially on the second one, is to put the boot on that protects your network connector. Because if you put your network connector on, you can't get this on. So you've got to remember to put that on. Then I'm going to take my stripper. I'm going to strip off some of this wire. Now I need to be careful, because when the final end of this wire is going to make up the overall length of the wire, and there is a specification for that length in the course, but I need to cut off enough, so you'll need to experiment with that a little bit and find the right amount. I'm just going to put it on this first one, and I'm going to twist this around a couple of times, not too much. Now I'm going to take this straight off and then pull this off. Now you'll notice that I didn't strip this off like this. I want to avoid two things. If by stripping it off I might strip some of the insulation off one of these wires, that would be bad. An exposed wire would probably cause the end to not work. Also, I don't want to squeeze on this when I turn it because I don't want to inadvertently score the insulation on these individual wires while I'm taking off the insulation on the twisted pairs. So we need to be careful of those things. Now I'll separate out these pairs. Need to untwist them a little. Separate them out. When I get this done, you'll notice that there are some kinks in this wire. We really want the wire to be a little bit straighter. So once I get these separated out, now you may want to take this end, it's a little softer, and straighten out some of these kinks. You want to hold on to this because with some of this wire you can actually pull these pieces through, and you don't want to do that. You don't want to pull through from the other end, you know, pull it through. But you do want to give it a little bit of a pull so that it straightens out, gets those kinks out. You might be able to do it two at a time. You don't want to use anything that's hard because, again, you don't want to strip this insulation off of the side of the wire. You just want to get the kink out from the twisting of the pairs. Sometimes you can handle them two at a time. Now that I have that out, I need to even these out. And what I'm going to do is I'm going to put them in the order that they will be in this connector. So I've got white, orange, and then orange. Put these together. Then I have white, green right here. Bring that around, put that there. Then blue, according to my diagram. Blue, white, blue, blue and white, blue, green, bring that around, green. Next we have white, brown, and then brown. All right. Get these together here, tighten that in a little bit, get them close, straighten them out a little bit. You need to even up the ends here. I'll even up the ends, get out here. I don't want to take too much off, but I do want to make those straight. I'm going to double check the order here, which they're in. I've got white, orange, orange, white, green, blue, white, blue, green, white, brown, and brown. So I'll take my connector and make sure that the tip is down, the clip here is down, and I'll go ahead and feed these in. Okay. Again, verify that they're in the correct order. Then I want to push this all the way in as far as I can. I want to make sure that the black insulation clears this notch because the crimper is going to push this notch down. It's going to push these pieces of metal into the individual wires, but it's also going to push that piece down. But what I need to do here is I've got this extra sticking out the end. I can't have that there. I got to get rid of that. You'll notice that there is a little bit of a lip here. So when I cut these ends off here, I'll cut even with that lip. Then what I have to do is I have to take this and I have to give it a little gentle pull and pull these wires just all together right back so that they're about flush with that end piece. And it doesn't have to be exact, but it should be close. You'll notice I've still got some of my insulation in there that this plastic will bite into. Then I'm going to go ahead and crimp my end. So I put it in this end, not that side, this side. And I plug it in just like I'm plugging it into the wall. Give it a good push, make sure it's in firm. I can look and see that it's sticking out the other end. Then I'm going to crimp one time, just one time. I'm going to squeeze good and hard until the ends come together. I can double check and see that's pushed that plastic up into there. I've got it pushed up in there. Then I'll release. And I may have to push down on my clip on the top and remove this just like I would out of a network plug. Set this here. It's all crimped in, so I'm going to go ahead and take my end and hold down this as you do it. You don't want this to go above the protector, the stress reliever. You want it below. Slide that all the way in there. There, it's all the way in. This way works just fine. It's all set. That end looks pretty good. All right. Once I have it assembled, have both ends assembled. I've got one here that is assembled, both ends. Then I'm going to test it with my tester. So I'll plug one end of my wire into here. You can see there's a phone line tester as well. Some of you may remember what telephone lines are. We used to make those. We used to use telephones that had wires that plugged into the wall. It's really weird. And when we did that, we used these to test those wires. I'll plug this in this side. You hear it click. I'm going to turn my cable tester on to steady, and when I turn it on, it's going to go down. It's going to test every connection. You can see every light come on, and if every light comes on except the ground, we don't have a ground in here, so there's no G. There are 8 wires in our 4 twisted pairs, and you can see that as it sends the signal through each one, the appropriate wire responds. Now, if you had twisted the wires a little bit, they might jump around, respond differently, or one might come on and another one wouldn't come on. That would indicate that you've made a bad cable. Go ahead and turn the tester off. And that is how we're going to make these cables. You want to take this now, this cable, and you want to measure it from end tip to tip and make sure that it is within the range of an acceptable part. Otherwise you have a blem. I wouldn't throw it away. You still might be able to sell it as a blem, but it wouldn't be a cable that meets the length requirements as specified in the assignment. All right, that's how you do that.